Today we are working on section 2.1, rates of change and the tangents to curves. Let's have a little bit review about average rate of change. So we know if we have 2 points, suppose we have point P, x1, y1, and the Q, x2, y2. We can find the slope between those 2 points. That should be the change in y divided by the change in x, which is y2 minus y1 divided by x2 minus x1. If those 2 points are on a function, so P and Q on the graph of the function fx, okay, so the P, we have x1, the y value should be fx1, we use function notation. Then Q would be x2, y2, that is x2, fx2. Then we say if you connect PQ, that will be the second line of this function. So the slope of second line, that should be change in y divided by change in x, which is y2 minus y1 divided by x2 minus x1. If you write in function notation, that will be fx2 minus fx1 divided by x2 minus x1. We know the second slope of the second line. This is also the same as average rate of change on the interval x1, x2. So from x1, x2. Here's the definition. Average of change, it should be fx2 divided by fx2 minus fx1 divided by x2 minus x1. Over here, if we let the change in y, if we let the change in x, theta x, x2 minus x1 equal to h, in this case, we can write x2 equal to x1 plus h. Then we can use a different way to find the average rate of change. We use fx1 plus h minus fx1 divided by h. In fact, all those formulas talk about exactly the same thing. You want to find the average rate of change, you basically use the change in y divided by the change in x. Now let's see some examples. Example 1. Given function fx equal to x squared minus 2x. We want to find average rate of change over the given function. Okay, so we write down the formula we're going to use. Average rate of change over the interval x1, x2. That should be fx2 minus fx1 divided by x2 minus x1. We're going to use this formula for this example. We can see over here, if we want to find the average rate of change, we needed to know fx2 and fx1 before we plug into the formula. In this case, for each question, we would calculate fx1 and fx2 first. Let's see A on the interval 2, 3. So we're going to calculate f2. f2 is the value of y when x equal to 2. Then we can now plug in x equal to 2. 2 squared minus 2 times 2. That is 0. Next, we calculate f3 is 3 squared minus 2 times 3, 9 minus 6 give us 3. The average rate of change on the interval 2, 3, that should be f3 minus f2 divided by 3 minus 2. f3 is 3, f2 is 0. So plug in, this is 1. So our answer is 3. Over here, I would like you to pay attention about our formula. You have 3, 2, 3, 2, okay, which follow the same direction. That's the first one. Second one, we want to find the average rate of change between -1 to 1. So first, find the value of the function at x equal to -1. Plug in -1. That's positive 1 plus 2 give us 3. The value at x equal to 1, -1. Average rate of change on the interval -1 to 1 is f1 minus f-1 divided by 1 minus -1. Plug in the values is -1 minus 3 divided by 2. So the answer is -2. We can see here for this kind of question, we do 2 steps. The first step, calculate the values at the 2 endpoints. The second step, plug in to the average rate of change formula to find average rate of change. Now let's see second example. We want to find the average rate of change of the given function gt equal to 2 plus cosine t. The same, we can rewrite the formula over here. Average rate of change on the given interval x1, x2. That should be f x2. So over here the function is t. We're going to use function g. So that will be g x2 minus g x1 divided by x2 minus x1. Okay. So for part A, we give an interval is 0 and pi. First, we need to find the value of the function at the given endpoint. So g0 is 2 plus cosine 0. Cosine 0 is 1, so this one will be 3. G pi is 2 plus cosine pi. That gives us 2 plus -1. Cosine pi is -1. So that's 1. Average rate of change on the interval 0 pi. We write the formula. That should be g pi minus g0 divided by pi minus 0. Plug in the values of the 2 functions. That gives us 1 minus 3 divided by pi. So the answer is -2 over pi. For part B, we have the interval -pi to pi. First, we calculate the value of the function at -pi. That would be 2 plus cosine -pi. Cosine function is even function, so we can take away the negative sign. That gives us cosine pi. Cosine pi is -1, so g negative pi equal to 1. G pi is 2 plus cosine pi. That's 2 minus 1 equal to 1. If you don't remember those values of the trig functions, You can use some chart. You can also use your calculator. Now we calculate the average rate of change on the interval negative pi to pi. That should be g pi minus g negative pi divided by pi minus negative pi. The top is 1 minus 1. Denominator is 2 pi. So we have 0 divided by 2 pi. The answer is 0. So be very careful when we use the formulas. Make sure you matched up the order of the variables. You see gx2, gx1, then the denominator should be x2 minus x1. We have g pi, then minus g0, denominator is pi minus 0. This is pi, negative pi, pi, negative pi. Make sure you follow exactly the same orders, and you will not make mistake. Next, we're going to see how we define average speed. So we say when you drop an object near the surface of the earth and allow it to fall freely, then we can use y equal to 16 t squared to calculate the distance that the object will move. Then we can calculate the average speed. This average speed during an interval of time is found by dividing the distance covered by the time elapsed. So we can write as a formula, you want to find average speed, that in fact is the change in the distance divided by change in time. Okay, so the distance, that will be distance at the end point minus the distance at the beginning point divided by the difference in time, which is t2 minus t1. Okay, that's how we defined average speed. Let's look at example 1. We want to find the average speed for the first 2 seconds. So for the first 2 seconds, that means on the interval 0 to 2. The first starting time is 0 and at 2 seconds. And we know the distance over time is defined as 16 t squared. In this case, we want to find the average speed. We needed to know the distance at time 1 and the distance at time 2. We're going to calculate distance at time 1, which is at 0 seconds. That should be 16 times 0 squared is 0. And the distance at time 2 is 16 times 2 squared. That gives us 16 times 4, which is 64. In this case, average rate of change or average speed on the interval 0 to, that should be distance at time 2 minus distance at time 1 divided by the difference in time. 64 minus 0 divided 2, so it's 32. Here should be 32 feet per second. That's the unit. Part B, from second 1 to second 2. In this case, our time interval is 1, 2. So we need to calculate the distance at time 1, at time 1, which is the first second. D1 is 16 times 1 squared equal to 16. And the D2 is 16 times 2 squared, we get 64. We calculated in the previous example. So the average speed on the interval 1, 2, or you can say from second 1 to second 2, that should be distance at time 2 minus distance at time 1 divided by the difference in time, 2 minus 1. 64 minus 16 divided by 1, which is 48 feet per second. Okay, that's how we find the average speed. Average speed is a special case of average rate of change. Okay. Now let's go back to introduce tangent line. We know for a given function, if you have 2 points, let's say P and Q, we connect those 2 points to form a straight line. This line we call second line. And we can always calculate the slope of the second line. Slope of the second line is the same as average rate of change on x1, x2. Okay, on this. And what we do is we can use fx2 minus fx1 divided by x2 minus x1. This is how we find the slope of a second line. However, if P and Q, if P, Q move closer to each other, until they meet. When they meet, now we can see P and Q become the same point. Then the line PQ becomes a tangent line of the function. That's the tangent line of the function. How can we calculate the slope of the tangent line? We can start from the second line. So we do 2 steps. First step, you consider P and Q are 2 separated points. Okay, so P, we have x1, f x1, and the Q, we use x2, f x2. Or we can write it differently, since we want those 2 points come very close to each other. We consider is the change from P, so we can make it as x1 plus h. Then the value of the function should be f x1 plus h. So here, don't get confused. It's basically just notation. We use x1 plus h to represent x2. It's just some notation. Okay, don't get confused. No calculation here. When we write this way, then we can calculate the slope between P and Q. So slope between P and Q, that will be difference in y minus difference in difference in y divided by difference in x. Let me write this a little bit more, one more step. We want to find the slope. That should be fx2 minus fx1 divided by x2 minus x1. Since over here we decide to write everything in terms of x1, so we can rewrite fx2 as fx1 plus h, and fx1 keep the same. The denominator x2 minus x1, that's the difference, which is h. Okay. In this case, we do not use x2 as the notation. We use x1 plus h. That's the first step. You can find the slope of this second line. However, we said for tangent line, that which is the 2 points come together as 1 point to form a tangent line. So we gonna let h equals 0. Okay, let h equals 0. Then you can find the slope of the tangent line. Okay, then you can find the tangent line. We can show you some examples to see how we do that. Let's look at this example. We want to find the slope of the parabola y equal to x squared at the point 2, 4. Okay, parabola, we use function notation fx equal to x squared, and we have point 2, 4, so that means x1. This is x1 equal to 2, and this is fx1. Okay, we want to find the slope. We consider 2 points. One point is the given one, 2, which is x1, fx1 is 2 and 4. Then the other point we consider q, x2, fx2. And this q is a point very close to P. So we can write 2 plus h, okay, which is x1 plus, let me write one more step. We want to write this one as x1 plus h and fx1 plus h. What is x1 plus h? That is 2 plus h. So the function should be f2 plus h. Okay. Let's do a little bit of calculation over here. How can we find f2 plus h? Okay, let me see where can I put it. Let me put it by this corner. We want to find f2 plus h. That is 2 plus h squared. We can use Fourier. Give us h squared plus 4h plus 4. So we can simplify a little bit more over here. That is 2 plus h and h squared plus 4h plus 4. We found the 2 points. Now we can calculate the slope between those 2 points. Okay, that should be fx2 minus fx1 divided by x2 minus x1. Okay, or you can write f2 plus h minus f2 divided by h. We plug in h squared plus 4h plus 4 minus 4 divided by h. We have h squared plus 4h divided by h. 2 terms divided by 1 term, we can separate them. So we have h plus 4. H plus 4. That's the slope of PQ. That's when you consider PQ as our 2 separate points. And now we want to let h equal to 0. H equal to 0. Then the slope PQ becomes the slope of the tangent line. Okay, that should be 0 plus 4, which is 4. That's the first question. The slope at this point equal to 4. Now, it also wants us to find the equation of the tangent line at this point. So we finished the first step. The second step, you want to find equation of the tangent. So for this tangent line, we have n equal to 4. We also have a point 2, 4. let's recall what we did in college algebra, how to find the equation of a line given slope and a point. We needed to use point slope form, which is y minus y1 equal to m times x minus x1. X minus x1. The given point is our x1, y1. Let's plug in. Y minus 4 equal to 4 times x minus 2. Simplify. Y minus 4 is equal to 4x minus 8. We can add 4 to both sides. That's y equal to 4x minus 4, which is our equation of the tangent line. That's the answer for the tangent. We can see here, in calculus, all the questions are getting much more complicated in college algebra or pre-calculus. It's seldom you can solve a question just in one step. It's always multiple steps. So you have to keep your mind very clear. The best way to do it, just write down every single step by step. Don't jump, don't hop, you will get there. Next, let's see another example. So this example shows the population of fruit flies grow in a 50-day experiment. So for this one, it didn't give us a function, just give us a graph. So we have to use the graph to solve this question. Let's see the first question. Find the average growth rate from day 23 to day 45. So let's have an interval day 23 to day 45. Okay. Average rate of change. So here that should be P at 45 minus population at 23 divided by the difference in time. So 45 minus 23. Let's check if we can see anything. When the day is 45, which is the point Q, 45, X value, the population, Y value is 340. And when X equal to 23, the Y value is 150. And subtract 340 minus 50 divided by 45 minus 23. We can see the chart is already give us the answer. It's 8.6. So that means it grow 8.6 flies a day. That's part A. Now let's see part B. How fast was the number of flies in the population growing on day 23? So if you want to calculate in day 23, you should use 23 to 23 plus h on this interval, right? That we needed to figure it out. Let's look at the graph. The closest point given over here, 23, let's see, 23 and the 23 plus f. We know at the point 23, day 23, we have P is 23, 150. The next closest point showed on the graph, in fact, is 30, okay, on day 30. So we use day 30, 30 to 65, yeah. If we have another point which is closer to 23, that would be even better. And over here, for all the information we have,
KMERSBY disconnected. Ready to pair.
we can see day 30 is the closest point. So we use the data for day 30. Then we find the average rate of change. That should be 265 minus 150 divided by 30 minus 23. Okay, we can use the answer from here, which is 16.4. Okay, this is just the approximate value. We're supposed to figure out a point much closer to day 23. But the only available one is day 30 over here. Okay. This is everything for today. If you have